Guys, this is the MS101 final project in which we'll be building a drone from scratch.
Throughout this video, we'll delve into technical aspects of drone technology, explaining key components and functionality.
First, let's introduce ourselves. Hi, I'm Kshitij.
Hi, I am Renudhruva.
Hi, I'm Aryan.
I am Seemon.
Hi, I am Aditya Rana.
For this build, we are using RS2205 2300 kV brushless DC motor. These motors come with cooling fins and high-grade N52 neodymium magnet. When paired with orange 3S lithium polymer battery and premium 5-inch propellers, this provides outstanding acceleration and high thrust value around 1024 grams. These motors come with two types of shafts, black being clockwise and silver being counterclockwise. However, it is to be noted that both the motors can have rotation in both the directions. It is the job of the operator to ensure that the connections are made in such a way that they are rotating according to their labeling.
The MPU 6050 IME sensor has an integrated 3-axis accelerometer and a 3-axis gyro sensor. It is an innovative product which is used for measuring tilt direction, vibration strength, resistance to shock, and acceleration in all three directions, that are X, Y, and Z, with high accuracy in millimeters and degrees. With the help of its built-in temperature sensor and digital signal processing chip, it can perform all these functions efficiently using minimal.
Arduino language is a subset of C or C++, where we can also use assembly for ultra-low-level code. The Arduino Nano has an 328 MP processor, which has a flash memory of 32 KB, of which 2 KB is used by the bootloader. A benefit of Arduino IDE is that it is compatible and portable. Arduino IDE is also cross-platform, which means it can be used on Windows, Mac, Linux, and even online. Another benefit of Arduino IDE is that it can be used in various Arduino boards and even compatible devices such as ESP32, STM32, Tensi, etc.
Arduino Nano is our drone good flight controller. Arduino Nano is a microcontroller device with a 16 digital pin, which can be used for various purposes. It can be used for almost every task, from minor to massive industrial scale projects. It can also be used for prototyping and making new applications. The Nano 33 BLE Sense not only features the possibility to connect via Bluetooth Low Energy, but also has the features to detect moisture, temperature, proximity, color, audio, and many more.
Node Microcontroller Unit, abbreviated as Node MCU, is an open source platform which provides Wi-Fi connectivity and is based on ESP8266 chip. It has the capability of 2.4 GHz and is programmed using Arduino IDE. Also, ESP8266 operational voltage ranges from 3 volt to 3.6 volt.
The Remote XY app is a system that allows us to create a graphical user interface for controller boards by using a smartphone or a tablet.
Using this, we can execute primary drone movements such as yaw, that is left-right turning of the drone, roll, that is rotation around the x-axis, that is the direction of motion, and pitch being the same around y-axis.
The battery used in our drone is a LiPo battery, which consists of 3 cells and has a voltage rating of 11.1 volt and 2200 mAh. We use UBEC, Universal Battery Eliminator Circuit, which converts the power source from higher voltage to a lower voltage from the LiPo battery, so that we can use the power from one battery source to the entire US.
In our drones, we are using the Seemon 30 ampere BLDC electronic speed controller, which is specifically made for quadcopters and multi-rotors, which provides faster and better motor speed control as compared to all other ESCs available in the market. This ESC can power motors up to 30 amperes. It works on the 2S, 3S LiPo batteries. It controls the speed of the motors by delivering timed electrical signals that are translated into changes in the speed. It directly uses the current from the battery coupled with a switch system that ensures to form a 3-phase current which powers the motor.
This version of ESC includes backward polarity protection and protection on the 5-volt receiver line, which means that if we attach a battery backward, it won't destroy our motor controller and other BECs won't affect the ESC. Here, we fixed together our carbon fiber frame that provided the basic structure of the drone and stacked up other components. Then, we meticulously soldered all the required connections on the power distribution board and Arduino Nano.
So we'll be using the Arduino IDE for changing our Wi-Fi ID and Wi-Fi password. We have changed our Wi-Fi ID from Remote XY to MS101 B12J, and we have also changed our Wi-Fi password from 12345678 to ABCD@123. We are also doing this so that our drone can be distinguished from other drones. Now we will be starting our calibration procedure. So in calibration, we want to ensure that the inputs that we give through the Remote XY interface give the desired output on the Arduino IDE and hence on the drone. So we'll be controlling the inputs through the Remote XY interface and we'll be expecting the desired outputs to be observed on the drone. So we'll be checking the yaw motion, the roll motion and the pitch motion by controlling the Remote XY interface.
In the ESC calibration, we tested all the motors and checked their directions. The silver motors have to rotate anti-clockwise and the black motors have to rotate clockwise.